Okay, this question on the bottom says, using the angle addition properties, prove sine 2a equals 2 sine a cos a. So basically, they told us this on the formula sheet, and we have to prove that it's true. Okay, so using the angle addition properties. So sine 2a, I'm going to replace sine 2a with an angle addition. So what could I add together to get 2a? What could I do as something plus something to get to 2a? 1a plus 1a. Okay. So that's the angle addition. Now, go to your angle addition formula. So that would be here. Can you replace with this expanded formula? So it would look like this. The sine of the first angle, the cos of the second angle, plus the cos of the first angle, sine of the second angle. Do you know what I mean when I say this is the first, this is the second? Okay, we don't have any b's in this one because the second angle is also an a. Okay, so now these terms are similar, right? They're like each other. So we can say this adds to 2 sine a cos a. And there we go. I just showed you that that is equal to that. Okay, that's a little bit of a warm-up. Okay, so today we're going to work a little bit more into this bottom section of a formula sheet. So yesterday we did these formulas, the add, subtract, so now we're going to work at the double A. So when I say this, it's doubled the angle. So again, if I'm going to describe the angle 40 degrees, the double angle would be 80 degrees. It's just doubled the angle. Okay, so we were given the sine of our angle, and we were given it's not in quadrant 4. I'm going to go down here, and I'm going to do a bunch of work. What quadrant am I in? It's not in quadrant 4. How do I know which one I'm in? Quadrant 3, because sine is negative, right? Doing sine negative, not in quadrant 4. So can you put a 3 and a 5 on this triangle? XYRs, where would you put the 3 number? Where would you put the 5 number? Put the XYRs. Can you find the third side of it? Okay, this is all last unit. So you should have a -3 on the y side, a 5. Pythagorean theorem and get that value. Did you put a -4? It's negative, right? Okay, let's write the cos of A is what over what? Okay, and all I'm doing is my XYR stuff here. X over the R. Okay, so this is preliminary work. I'm done my preliminary work, so now I'm going to go to the formula. So sine of 2a. Find your formula sheet. Sine 2a is 2 sine a cos a. 2 sine A cos A. That's the formula. So now I'm going to go like this. 2 bracket, bracket. So I'm going to replace sine A with some kind of trig value. I'm going to replace cos A with some kind of trig value. And guess what? We just did all that work down here. So sine A can be replaced with -3/5. And cos A can be replaced with -4/5. And just for easier brain here, we're going to put that over 1 if that's okay with you. So then I can multiply all top, all bottom. So can you do that? Multiply the whole top. You should get positive 24 over 25. Okay, now I'm just going to clarify this because some people get confused. They're like, well, why is the sign of this all positive? Why did we end up positive? Because I want you to think about an angle there. What if you double that angle? Where would you land if you doubled it? So you would land, let's pretend it's a number. You would double, you would land what, here? And then sign would be positive. That's kind of idea. That's why you're changing signs, because it's doubling the angle, so now you're landing somewhere else. So now the sign value is positive. Okay, so cos 2a. So go to your formula sheet. Ooh, I got options. I have 1, 2, 3 options for this formula. Okay, I kind of like this first one better. Okay, you're going to get to the same place no matter which one you pick. I'm going to go with the first one though. Okay, now here's what I'm going to do. I'm going to put brackets squared minus brackets squared because I'm going to put the trig value but square it. Okay, cos A, find it. We've already figured it out. So cos A, sine A, make your replacements. All right, so I get positive 16 over 25. Subtract positive 9 over 5, 7 over 5. What? 25. 25. So I guess I ended up technically in quadrant 1 when I doubled. That's where I would have ended up then, once I doubled. Here, doubled, I ended up in that quadrant when I doubled. Okay, tan 2a. Now you have 2 options. Option 1 is that you could do this formula. That's option 1. Option 2 is that you could do sine 2a divided by cos 2a. Those are your 2 options. Okay? The reason that this is a good option is, guess what? We already did all this work. Okay, and you know why I can make this replacement? Is because tan of an angle is y over x. Y is attached to sines, and x is attached to cos, right? So that's why you can do that. Okay, do you want to do both? Just to see that we're right? Okay, I guess we should write down here, what is the tan of A here if we did our preliminary work on tan? what over what? Negative over negative, so then I'm just going to write positive out of it. Okay, so we're going to go 2 times the 3/4 divided by 1 minus 3/4 squared. So then, this is a 6/4. I'm going to do this right here. This is 16/16. 1 is 16/16. And this is 9/16. So then this would be 7/16. Two fractions divide, flip multiply. Can I wipe this off? And this, replace with a 4 and a 1. So I got 24/7. Now I definitely know I'm in quadrant 1, right? Because they're all coming out positive. So if you doubled that angle, you would land in quadrant 1. So if I had tried this other method, sine 2a, which was 24/25, divided by cos 2a, which over here was 7/25, what happens once I flip multiply? The 25s would be gone, and what do we get? Same fraction, right? So there you can see that they both would work. Okay, secant. You should be thinking, well, what's the flip? Secant is the flip of which one? It's the flip of cos. So did we find the cos of 2a? Yep, we found the cos of 2a, and what should we do with it? Flip it. No, that's it. Just for you to understand, whenever you see secants or cosecants, do your work with sines and coses. Okay, this bottom question. If I'm given the cos of 48, find the cos of 96. What's the relationship between 48 degrees and 96 degrees? It's a double. So I'm going to be working with this, cos of a double angle. Okay, so there's 3 options on my formula sheet. Cos of 2a, there's 1, 2, third. So this is the first, the second, or the third. Given the question information, only one of these we can work with. Which one of those 3 can you only use because of what I gave you? Can I use this one? Nope, I can't, because I don't know what the sine of this angle is. This is the cos of the angle. I'm trying to find the cos of the double angle, so I have to use the bottom one. So 2 cos squared a minus 1. So 2 brackets squared minus 1. So thinking about what am I replacing cos a with? 0.67. Okay? Just wanting to understand that. I'm going to type it into my calculator. Whoop. Okay, so double angle formulas, that's what this is doing. So sometimes you just have to be ready to, given and given, you might have to recognize, hey, that's a doubled relationship. Okay, so now we're going to go back to the addition formulas. So we're back to these formulas, but we're not going to work on our unit circle, we're just working x, y, r's. Okay, so here we go. We are given an A angle and a B angle. So let's go A and B. We know A has a negative cos. Where could you be right now with A? The left. Tan of angle B is positive, so B is allowed to be in quadrant 1 and 3. Both angles are in the same quadrant, so therefore both are in quadrant 3. So that's the first kind of step. Figure out where your angles are. Okay, so now give me a 7 and a 25 on that triangle. Where would you put each? X, R. Are you starting to get that all memorized? Pythagorean. Does that one come out nicely? Yeah, it does. Came out to a 24 plus or minus, location-wise. Negative. Okay, let's jump into B. Put a 15 on there and an 8 on there. 15 and an 8. You got it down with a Y and an X. Y and X. That doesn't make sense. Location. Negative. Okay? Obviously, once I divide two negatives, it's positive, so that's why you don't see positives. And then what do we get? Anybody already do it? Is it 17? Okay, I'm going to write the fractions. So the sine of A, y over r. The cos of A, x over r. Sine of B, y over r, and then x over r. Okay, all old work here. We know how to do this. We know how to find x, y, r stuff. We know our ratios. So now we're putting a twist on it. We haven't even got to the question. Here's the question. Can you get me the trig value for the cos of the A subtract B angle? So what are you going to do? Grabbing your formula sheet, right? Cos A minus B. So copy that one down. So cos A cos B plus sine A sine B. So we copied from a formula sheet. Okay, next I'm going to put 4 brackets. Okay, you've already done the work. You're ready to just fill in from your chart. Okay, this was all the preliminary work we did. So can you put everything in its place? Do we get the same number? Matched? Okay. At this time, you don't have to do any positive, negative work. It came out positive for a reason. So think about if you had an angle measuring in here and another angle that measured in this quadrant and you subtracted them, okay, you would land somewhere different. And then it changes the sign. Okay? All right, last question. And then we're actually done the whole first booklet. That was it to the booklet. Okay, so same idea here. Let's go A and B. We're going to have to figure out the quadrant. Neither angle is in quadrant 1. So, well, you can't put anything in quadrant 1. Cosecant is the flip of sine, and the sine was positive, so it has to be in quadrant 2. I'm going to put the 5 on the R, and I'm going to put a 4 on a Y. Maybe you have this memorized. 3, 4, 5 is a triangle all the time. -3. Okay, same work over here for B. What quadrant are you in? Tan is positive. So you're in quadrant 3. I'm going to put a 12 on a y over x is the ratio, right? Y over x. Negative, negative, because of the location. A squared plus b squared. Okay, preliminary work. Can you just get me all the 4 ratios here, just nice and organized? So at this point, you should kind of have those 6 ratios nice and memorized. So again, you would not even get those on the exam. Okay, so here's the actual question now. So we haven't even started the question. Find the cos of A plus B. So go to your formula sheet and write the formula that you would find. So it's a cos minus a sine. Then I'm going to give myself some brackets to replace the trig values into those positions, and you have them all organized. So really just be careful with your plus, minus, integer math stuff, I guess. Okay, next part, find the sine of A plus B. So get a formula written down, sine A plus B. Once you have your formula done, you can put brackets. You already have your stuff in your chart, organized, ready to go. Fill them in. Okay, when you look at your formula, it's nice to glance that all 4 of these are different. Make sure you didn't repeat something, right? Somewhere you should have plugged all 4 of them in. Okay, and then the last piece is just tying stuff together here. When you write a coordinate of a point, you always write points x comma y. So in trig, what do we use for x? We use the cos value. So the cos of a plus b, comma, and then that's how we would write the coordinate. So then we would go 63 over 65 is the x, comma, the y. Okay, so this tells me that when I added this angle plus this angle, I ended up resulting in which quadrant? If your coordinate is here, what quadrant are you in? When we added the 2 angles together, would that make sense? If you put a number like this together with a number like this, you would end up adding to some kind of number that would get you into quadrant 1, right?